Okay, so this is the image that you need to see for right now to understand where they decided that waves were really important in quantum physics. What you need to know is that waves are real in the forms of matter, but how they actually work is depending on what kind of wave you're talking about and what system. The problem with this whole wave theory that they've come up with is that really waves, atoms are not waves. They may be oscillating or in motion, but you don't call an atom a wave directly. It may be like in motion, but atoms are not in motion like as an actual sinusoid type wave, like positive and negative hill arches, or positive and negative arches, as like an arched wave, a sinusoid arch. We don't really have sinusoid arches. What you don't know is that the world of quantum physics is right now currently ignorant, and that what was hypothesized by the previous scientists is wrong. We do not travel time. There's no way to reverse time. You cannot take all of the particles of time and put them back. You cannot reverse time. Okay? It's completely ridiculous to think that you could. And these people that are all physicists are extremely probably religious and delusional. They do not understand the concepts of what we call geometry. The whole process of life is based on geometry and its distribution. So if you look here in this image, you'll see a speaker with little atoms that are actually moving what seems to be in a straight line from the speaker to what is a really crappy, jumbled up image of an ear. It's supposed to be an ear that connects your eardrum to your brain. Okay? So, and then there's an expanded view of an eardrum at the bottom. Basically, an atom's hit a speaker. If you think about the pattern that which they move, they don't look like a sinusoid wave. Okay, that's not at all how atoms move when they're being forced as an air pressure. Okay, as a matter of fact, if you have enough force behind it, like a very loud speaker, it moves in a straight line. Okay, the air is not waving at all, as a matter of fact. It might be moving at how many ever feet per second, but that's the problem, is that it's not really necessarily it is bouncing off of other air molecules, but in a short distance. Actually, what it does is it acts like balls in a pipe. And from me to say 10 feet away from a really loud speaker, that air, it doesn't wave as much as you think. It's actually straight line, just like balls in a pipe. Okay, light actually does this too at angles from electrons and moves at different degrees of angle from the electrons and diffracts as patterns that appear to be like waves. There's this guy on the internet from Action Lab. He calls his channel Action Lab. He's not a very good quantum physicist. He doesn't seem to understand that he is at the wrong scope when he describes the physics of photons and light. Not only that, the photons that he's showing and the pictures and the different videos that he's shown on light is at the wrong quantum scope. For one, he doesn't know anything about any other angle than the linear pathway. He only seems to understand like linear pathways. And as we were viewing a laser from his video, it was a green laser, and it was clear that the green laser was diffracting to the camera, but it was dense in its direct path, which was away from the camera. So we could obviously see that light diffracts. Light is obviously diffracting. This guy doesn't seem to get it, okay? And he doesn't understand that photons, and so the science of photons is not a well understood science right now. Wave theory is not well understood either. Actually, at the quantum level, this guy doesn't know his quantum math very well either. Is that at the quantum level, everything at the most quantum level is nothing but the angle of a line. Everything in the most quantum level is nothing but an angle of a line. At the smallest point possible that we could conceive physically. Not the absolute smallest, just the smallest we could probably conceive physically is just the angle of a line. Okay? But in the real true existence of life and the universe and anything that could exist, you cannot have anything unless it is a geometrical figure. You cannot have any object of existence that is 1D. 1D does not exist. 2D does not exist. Okay? Nothing is really 2D. But 3D is a cube. It exists. Okay? It probably exists in particle physics. We don't know what particles actually look like. And particles could very well be cubes. All of life existence could come from a cube because it is the simplest primary geometrical figure. You cannot actually have 5D as well. Every so many Ds, it's impossible to make a figure out of it because it doesn't form a part of a three-dimensional figure. It's a missing link in a three-dimensional figure. For every one three-dimensional and multi-three-dimensional figure, or sometimes you can add 2 dimensions to a three-dimensional figure, and it actually is a three-dimensional figure. For every dimensional figure, it has to be 3D, or it has to have volume, to say the least. So, nothing can exist without volume. If you can say ignorantly that light moves as a wave and does not have any particulate volume, you are an immortal retard. And if you are an immortal retard, then basically you're in heaven. There's angels everywhere, and monkeys fly out of my ass. Okay, monkeys do and probably fly out of my ass in your opinion because you're most likely a psychopath. And that how you think in your IQ is probably very low. But when you really get down to quantum physics, which you probably don't understand is mathematical. And it is a shape. Okay, and it's a lot of different shapes in motion. And this is all of what we call particle physics, okay? So if you're foolish enough to believe that everything isn't made of particles and that it is in motion, you're an idiot, okay? As you can see here, F equals ma. The eardrum is what's doing the waving for the most part. When the speaker actually forces at a short range the waves of the well, we're calling them waves, but they're not really waves, they're just balls in a pipe. But the gas molecules, or whatever, they actually move like balls in a pipe in almost probably a straight line for the most part. They may actually undergo other motion, but that's not until it actually is confined enough to bounce around. So in just an open airspace with a loudspeaker that's playing close to an eardrum, all that's really doing the difference in sound is the different forces of mass and acceleration. Okay? And that mass is gravity, and mass is also force. So force equals all of the forces combined times the acceleration, which is all a force. So force is equal to all of the forces combined and any acceleration that they might have. You don't have to add acceleration. You can just call it all a mass, or you can say it's all an acceleration. Okay, but it's all actually just a force. Okay? And particles are all particles. Light may not actually be waving at all. It may only be streams of particles that are diffracting. And they are potentially just ultra tiny particles that emit from electrons that diffract at angles, and they form what seems to be in the photon experiment, in various photon experiments, which seems to be at the wrong quantum level, a wave pattern, which is actually just a diffraction pattern. It's not a wave pattern. The quantum level is much smaller than what you can see in those patterns with your eyes. We don't grasp the measurements because obviously none of the people have put a microscope up to light to see it at the point at which it is actually its own size. Okay, we're seeing it at like maybe a millimeter versus seeing it at the femtoscopic level that it is. You need to get down to the femtoscopic level to actually see, well, either nanoscopic, it's not typically microscopic as much. It depends on the amplitude and all that. You're talking about something that is said to wave, but I don't think that it necessarily does. I think what really generates a wave in light, when we discover the frequency of light, it's not that it's waving, it's that it's like balls in a pipe. Okay, it creates a voltage in electrical circuits. When you send a signal out from your cell phone, it streams a direct line of photons as a voltage. Okay, each particle equals a voltage. They're consecutively behind each other in like balls in a pipe. And each one that hits a sensor or an antenna creates a voltage electrical signal in the antenna. Okay? So when it hits the antenna, the voltage spikes up, and immediately the electron will leave its orbit and go back to its orbit. When the next photon hits, it does that again. It repeats. And for how the photon emits in the distance between each photon is the frequency of light. Okay? It is not because you're actually seeing any waves at all. Photons may have their own specific charge, and they also may have their own specific momentum or force. And how they do that is also how they are gapped and spaced between each other. Okay? Anything that we've ever seen known as a wave of light is at the wrong quantum state. We have never seen light in its actual singularity state. Okay? What we've seen is diffraction patterns. We've never seen light at the single photon level. We've never seen this. Okay? I have never seen this. No one has ever seen a single photon. It'll be the day that you can ever build a sensor that will show you a single photon. You will never actually ever see one until you learn to use different quantum physics to show you how larger photons either wave or they don't wave. First of all, I have an experiment called a transjacent large photon wave detector. It is transjacent cameras that detect the shifting of a photon that could wave with a large amplitude and a large frequency. Not a high frequency, but a low frequency. Okay? So a low frequency with a large amplitude in the shift of the nature of entropy, you should be able to detect in adjacent cameras the actual points at which a stream of large wave photons bounce at different points in the camera pixels. So therefore, you should be able to say if this environment is quantum enough, which it cannot have any light in it whatsoever. It has to detect that specific frequency. It also has to detect, has to be a condition that's absolute. You can't have any interference whatsoever. It may have to be sub-zero temperature. It may have to be in like some kind of a pitch dark black box that's void of light, and I have no idea how you would ever make something absolutely void of light, except to reduce its temperature. And I'm not even sure you could absolutely achieve this, but it's probably the only way is to reduce the temperature, absorb all the light, and block out all of the light. And then you have to run electrical circuits that emit light just to detect it. Otherwise, you would have to use like some type of scattering effect with a type of like photo material that will detect the wave as a single wave of large wave properties, large wave photons. But I don't see that as ever happening right now. And the photon split experiment, and the other photon experiment where they do the path of light and diffraction and comparing it to time travel and all this. The guy showed on the Action Lab. That was ridiculous. That is not quantum physics. That is shit. Okay, that was just a laser, a small laser, diffracting in some fucking junk detector or whatever. It was useless. It was not a quantum experiment. Quantum is much grander than just beaming some light into a mirror. Everything's quantum, but that's not a real good indicator of something that's quantum. Quantum is really down to the particulate level of identifying really finely tiny small objects. You don't do this with gigantic laser beams the size of, say, a millimeter. If it's the size of a millimeter, first of all, it's not something that you find to be extremely quantum. It's quantum, but it isn't the real true nature of quantum physics. So, it was completely ridiculous of how this guy described his theory and claiming that that wave is how they describe everything in mechanics, in quantum mechanics or whatever. Absolutely not. Waves are not everything, buddy. I mean, there's tons of reasons to believe that there are other motions and that waves are a formality of many. There are things that don't wave whatsoever. There are things that just oscillate back and forth. I mean, you're ridiculous in how you've worded quantum physics, and you've misled tons of people. I won't say that quantum physics is an absolute science right now. And even Einstein, they claim him to be genius, and a lot of other scientists made a lot of claims. They weren't as smart as everyone thought they were. There were just a lot of dumb people who believed that Einstein was really all that smart. Okay, there's a problem with Einstein's traveling time theory. It's not possible to reverse time. That's just one reason that Einstein is dumb. You cannot reverse time. Plain and simple. Traveling time is nothing more than inevitable, or it's also evidential that time travels no matter what. But how does it travel? In the past, the present, or the future? Actually, the future doesn't exist yet, or it became the past, and you're really only in the present. So, you can't reverse time. Time marches forward. It doesn't go in reverse. And these idiots are delusional. They just want to believe any fucking thing that people say, and it's ridiculous. If you think time's so possible to travel, buddy, other than using your automobile, your airplane, your rocket, and your 2 feet, and maybe your wheelchair when you get old, maybe, just maybe, you have to go ahead and hop in your little time traveling machine and go back and fix your science knowledge, probably. I think that would be best. So this is my video on what we call the lies of wave theory and quantum physics.